Alright, so running through the Examcraft 2020 paper 1, question 1b. So the induction question on the paper. So I'm asked to show that n on n plus 1 on 2n plus 1 is divisible by 6. I've already done the p1 step. I subbed 1 in. It's equal to 6, which is divisible by 6. So then it's assumed pk is true. Now, I said to you when we were doing these that was the ideal, and certainly when you get if you do maths at third level, will be to make the left hand side equal to the right hand side. So basically to kind of deal with it in its current form. But I think just looking at this one, I think this is going to be easier if I multiply that expression out. So rather than showing this thing here is divisible by 6 and dealing with that in the pk and the pk plus 1. Now, I think that will work, but I think my life will be easier if I multiply this out. Okay, so if I multiply this out, I've got n squared plus n on 2n plus 1, and that's equal to n squared by 2n is 2n cubed, n squared by 1 is n squared, n by 2n is 2n squared, n by 1 is n. So that's 2n cubed plus 3n squared plus n. Okay, so I'm showing this is divisible by 6, okay? And it's completely fine to do that, okay? So assume pk is true, 2n cubed plus 3n squared plus n. And the way we say is divisible by 6 is to say it's equal to 6a. So basically I can factorize 6 out of it, okay? So step 3 then is to prove pk plus 1. So if you want, you can go back here and multiply it out again, but look, it's put k plus 1 in here instead of, well, sorry, I should have these in as k's. But plug k plus 1 in instead of k. So it's 2 on k plus 1 cubed plus 3. Instead of k, it's k plus 1 to be squared. And instead of k, it's k plus 1. And we're going to work away on this. So I have to expand out k plus 1 cubed. There is a quick way of cubing these out to remember. I never remember it, so I just tend to go, it's k plus 1 times k plus 1 squared. So k plus 1 squared, I do remember the quick way of doing that. It's k squared plus 2k plus 1. Okay, so if I multiply this out now, I'm going to get k plus 1 cubed. So k by k squared is k cubed. K by 2k is 2k squared. K by 1 is k. 1 by k squared is k squared. 1 by 2k is 2k. And 1 by 1 is 1. So putting like terms together, I've got k cubed. I've got 3k squared, I've got 3k, and I've got 1. Okay, so that's what k plus 1 cubed is equal to. Okay, so there's k plus 1, there's my k plus 1 squared that I just kind of did in my head. So it's 2 times all this, k cubed plus 3k squared plus 3k plus 1 plus 3 on k plus 1 squared, then that's this bit, it's k squared plus 2k plus 1 plus the k plus 1 at the end. Let's multiply this thing out. 2 times k cubed is 2k cubed. 2 times 3 squared is 6k squared. 2 times 3k is 6k. 2 times 1 is 2. 3 times k squared is 3k squared. 3 times 2k is 6k. 3 times 1 is 3 plus k plus 1. All right. Now, what we do with these is we isolate one of these, okay? And then we're going to sub in for it in the pk plus 1 step. It'll work with, assuming you've got a 3k squared. You actually, you probably don't have a choice here, because you don't have a 3k squared. The only thing I think it makes sense to isolate, and it's the one I would have defaulted to isolating anyway, is this one. So rewrite your pk step as 2k cubed, leave on the left hand side, move everything else over to the right hand side. So you've got 6a, bring 3k squared over, it becomes minus 3k squared, bring k over, it becomes minus k. So that's my pk step now. So I can sub in for 2k cubed. So I've got, instead of 2k cubed, I've got 6a minus 3k squared minus k. And then I'll tell you the rest of this anyway, and then we'll do that. So I've got 6k squared and 3k squared. That's 9k squared. I've got 6k, 6k, and k. So that's 12k, and another one is 13k. I've got 2 and 3 and 1, so that's 6. Now, let's introduce these lads. So 6a, I've got 9k squared and minus 3k squared. That's 6k squared. You see this, yeah? I've got 13k and minus 1k, so that's 12k. And I've got plus 6 at the end. And what you'll notice is I'm trying to prove divisible by 6. All of these things, I'm able to factorize 6 out of them. So that's equal to 6 on a plus k squared plus 2k plus 1. Okay, because you are able to factorize 6 out, you've proved the thing. Okay, therefore Pn is divisible by 6, and I think it's all natural numbers, isn't it? So for all, yeah, we were able to sub one it, so it's for all natural numbers. So that's that question done. As I said, if you had have left this as n on n plus 1 and 2n plus 1, you might have been, say, I don't know what you would have been isolating, n plus 1 maybe. So let's say you would have had n on n plus 1 on 2n plus 1 is equal to 6a, and then let's say n plus 1 might be what I'm able to sub in for. So you'd have n plus 1 is equal to 6a over n on 2n plus 1. So then you'd be subbing this in here. I just think it works out more difficult to do, so I would say multiply this out, and it's fine to do that. Okay, so if that helps, if something like this comes up in the exam, and it's going to be easier if you expand it, if you multiply it out. Same way you can do a little bit of messing with the right hand side and some of those other ones, like the series ones, if they make it much easier, by all means do it. Okay.